We're in probability at the moment, yeah? And I really love probability because of just how grounded in reality is. We have to make decisions on the basis of probability all the time, but usually we kind of do it intuitively. Like even when you've got numbers, like you look at the weather app and you're like, oh, 19 degrees today, and there's a 47% chance of rain, we still kind of, I think, resort to feeling intuitively, do I need to bring an umbrella or do I just not bother, right? And the great thing I think about these things mathematically is you can go beyond what your just normal intuition can handle because the numbers are far more accurate. Now, in the situations that we've been having a look at and answering questions in, you guys have already had a look at a few different visual tools that you can use to help you understand particular scenarios. Would anyone like to help me remember? Just go back to yesterday afternoon. What's an example of one visual tool that we know we can use in probability that helps us understand a situation? Any takers? Go ahead.
Tree diagram.
Tree diagram. Okay, so let's all put these in no particular order. A tree diagram, very good. Can someone give me another one? Yep.
Arrays.
An array, thank you very much. Which in the past you might have called a dot diagram, but same deal. Now, these two are probably the main one you spent some time on. I'm going to give you another two. One of them which doesn't even feel like a visual tool, but I'll justify it in a second. If you have a lot of different sort of parts of your event, you use a tree or an array, but sometimes a situation is sufficiently simple that if you just take all the options in the sample space and just put them in a list, just make sure you've got all of them there, you have a comprehensive list so you can say, here are the ones that are good, that are favourable, here are the ones that are not, that's fine. Okay? Now here's the important thing, and I know you spent a little bit of time thinking about it, but not heaps. You need to know when it is that you use each one of these tools, right? The whole idea is we're giving you like a toolbox and there's a hammer and a screwdriver and a wrench in there, and we want you to be able to use all of those tools, but just as important is knowing when are you supposed to use a hammer instead of a screwdriver. I really hope you would know when to use one or the other. So let's have a think about this, right? I'm actually going to start at the bottom here, and I kind of clued you into this. In what situations would you just list out all of the outcomes in the situation? You probably don't want to do it when there's a lot of different things, right? So in other words, when do you use a list? When there's a very small sample space. If you have a look at your scenario and you're like, wow, there's only 4 different things that can happen here, right? Well, don't use some big fancy tool for it. Just say 1, 2, 3, 4, bam, it's all there, okay? All right, that was me sort of holding your hand. Let's have a think about an array. Under what circumstances, because you can't always, under what circumstances would you use an array to visualize your situation? Have a think. You may like to look back in your book for when you did use an array. If you used an array a few times, have a think about what's in common between each of those situations.
I even told you guys.
Yeah, come on, think back. This is very important. What do you reckon? Yeah?
I'm just saying an example.
That's fine.
Like if you have 2 dice.
If you have 2 dice, and I'm going to say 2 dice is like the classic situation. It happens so often. I'm glad it's where your mind first went. That's an example. Did you want to give me another one, Anuja, or same one?
Yeah, same one.
Same one? Yes, something different.
Is it when like when you have like 2 different variables and you want to be able to record and like kind of compare them?
Yeah, very good. So don't worry about drawing this, but that's pretty much bang on. If you think about what an array looks like, for example, with the 2 dice, we go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? You could, for example, if it was any 2 events, you could say maybe rolling a die and then flipping a coin. Yeah? You would still go 1, 2, 3, 4, 5, 6, and then you would just say head, tail. But the key is, if there's 2 situations, you can represent one horizontally, one vertically. I should say 2 events, right? If there was just one event, just rolling a single die, this is a bit pointless, right? Like, why would you need both things? And by the same token, if you were, say, flipping 3 coins, you can't really use this tool, can you? Because you go first coin, second coin, uh-oh, you're a bit stuck, right? So therefore, and that leads us to the next thing, right? When you use an array, it's really when you've got 2 parts to the event. 2 parts to the event. So maybe that leads you into thinking about, at the moment anyway, the most complicated tool that we have for visualizing situations is a tree. Maybe you can kind of see, if you can follow the pattern, under what circumstances would you use a tree?
One part of it.
Say it again.
One part of it.
When there's a one-part event, now think about this with me. Let's give an example. A one-part event might be, say, I roll a single die. Would we use a tree for this? Or would one of the other tools be more helpful, perhaps? What would you do if it was just rolling one die?
I would use the list.
Yeah, I think so too. 1, 2, 3, 4, 5, 6. It's simple, but it gets everything there. I'd actually probably want not a less complicated event, but probably a more complicated event would be more appropriate for a tree. Does that make sense? What are you thinking?
When there's like 3 or more.
Yeah, so I guess a way we could say that is when there's like a multi-part event, especially when there's more than 2. Now, there's one other thing, and if you've got another color there, it might be helpful here. You remember when I mentioned, doing 2 dice, right? 1, 2, 3, 1 to 6, 1 to 6. One of the key things that we tend to use arrays for is when every single one of the options, every single one of the possible combinations, when they all have equal chance. If every single option in your array is equally likely, right? We don't tend to distinguish. We're like, is it more likely to roll a double 6 or a double 1? And the answer is, well, they're the same, right? Every single event has an equal chance. What is it about a tree diagram that makes it a bit more useful when you don't have equal chance? You know what I think about it?
Yeah, when you can write the chance on like the line that connects them, and then you multiply them and you can add them up.
Yeah, nailed it, fantastic. So if you've got your tree here, right, as was just mentioned, we could put like, different numbers, different fractions on these branches as you've seen before. And what this indicates is one thing is more likely than another. So not only, sometimes, even when you've only got 2 parts to your event, you'll use a tree anyway, like this, because you have varying chances of your different, that's a G, of your different things, right? So this is just sort of making sure that you've got a handle on, you need to be able to use all these tools, but when to use them is just as important. Okay, now here comes the heading, by the way. We're going to talk today about the 4th visual tool, which is something you've actually used before. It's a Venn diagram, right? Can someone verbally describe for me, what does a Venn diagram look like?
It will be 2 circles that overlap each other.
Yeah, generally the most common thing you'll see is 2 overlapping circles. As you're going to see in a second, sometimes it will not be exactly that, but that's the basic idea, okay? That's going to be our heading, by the way, Venn diagrams. Now, hopefully this big gaping hole in the table is begging the question, okay? When you've got a simple event you list, when you've got a 2-part event and everything's equally likely, you use an array. When you've got perhaps many parts, 3 or 4, or when the parts all have different chances, that's when we use a tree. You don't have to write this, but I want you, by the end of this lesson, to be able to answer for me, in what circumstances is a Venn diagram the way to go? And I'm not going to tell you, I'm just hopefully going to walk you through enough that we can do it, okay?